Hi there, and welcome to Mondays with Mike. It is Monday, February the 24th. I'm Mike, and so we do Mondays with Mike. Today, we're going to be talking about the crazy ups and downs that we have had so far this winter in Houston, but also across the state of Texas, and really, for that matter, across the country. What's been causing it? What are some of the factors that go into it? Um, and the fact that sometimes what you think is going to happen longer term does not happen. So beginning, I put together a couple of statistics behind me that I think might be surprising to you. It's pretty amazing. So in Houston, when you look back at just the month of February, and we're only 3.5 weeks, we're almost done with February, but February is a short month, but just over the last 3 weeks or so, in Houston, our hottest temperature, you'll see here, was 86 degrees, and that was back on February the 8th. The coldest temperature we've had this month, 27 on February the 20th. So, give or take about a 60-degree temperature range that we've had here in H-Town. And some people might say, well, that's Houston for you. Well, you know what? It's a lot more extreme in other cities. Let's just take Dallas, for example. Now, these are the numbers from DFW. The hottest day they had was also on February the 8th, 88 degrees. And the coldest day was 12 on the 20th. Okay, so from 88 to 12. I mean, that's a lot more extreme as far as the temperature change there. I mean, we're talking about, give or take, almost 70, more than a 70-degree change in temperatures. What about Amarillo, Texas? That's where you really see the crazy temperature extremes. So get this, the hottest day for Amarillo in the month of February, February 3rd. Why did I put thirth? You see how I put thirth? Third. 89 degrees. The coldest was 2 degrees on February the 19th. From 2 to 89. That's an 87-degree range of temperatures in Amarillo just in the month of February. So I know that here in Houston, no doubt, yes, we get some big temperature extremes. We have a lot of extremes going from, sunny and warm to cold and wet and all that kind of stuff. But there are other parts of the country, even in our own state, that have the craziest temperature extremes. Amarillo happens to be one of them. And a lot of that just has to do with the fact that when there's a south breeze across Texas, they get really very, very warm. I mean, hitting almost 90 in February. When there's a cold front that comes down, they usually get much, much colder than we do. So they go through some big extremes. You could also take a look at some cities in Oklahoma and Kansas that get really, really big temperature swings. One of the ones that I noticed this morning was up in Nebraska and in North and South Dakota. That's an area where they were down to like minus 30, minus 36 or so. It was pretty typical of that area, not counting wind chills last week, minus 36. Now, this morning, they're waking up to temperatures above freezing, and they could make it to near 50. So again, you're talking about like an 86-degree temperature change in 1 week. So that's pretty wild. So what are some of the factors that go into this? Well, we're going to talk about the La Niña here in just a little bit, and the fact that La Niña was kind of a dud. Really just did not do what it usually does. We also are going to talk about the jet stream and the polar vortex. Yes, the polar vortex. So the polar vortex, sounds like a very scary thing. It also sounds like it might be a new thing. Well, it's not new, and it isn't necessarily scary at all. It's a very natural part of the Earth's global atmospheric circulation. It is omnipresent, if you will, there at both the North Pole and the South Pole, particularly well-defined during the winter season of both of the poles, or each of the poles. It's something that's been studied for probably going on maybe like 60 years, probably going back to like the 50s when scientists started to discover it with the use of weather balloons. Because before then, see, well, let's just start at the beginning. What is the polar vortex? Okay. Well, there are actually two definitions for it, and it really is difficult because you have sort of the original scientific study was on a stratospheric wind current. So we have different layers of the atmosphere. The lower layer, which is about the bottom 10 kilometers or so, that is what's called the troposphere. And the troposphere is where all the weather happens, basically. Thunderstorms are in the troposphere. Cold fronts, warm fronts are all in the troposphere. We live in the troposphere. We breathe in the troposphere. So that's all. The next level above that is the stratosphere. And that's where we have things like the ozone layer that protects us from UV radiation. You can also, we have some aircraft that can fly into the stratosphere. Like, for example, you remember the SR-71 Blackbird? It was a spy plane that we had back in the 60s. It was amazing. Traveled at like Mach 3. Well, that one flew into the stratosphere at about 70,000 feet, or maybe even a little higher. Otherwise, though, stratospheric conditions are not something that we think about on a day-to-day basis at all. But in the stratosphere, around the North Pole and South Pole, is a circulation. Now, this is way up there. So we're talking about, let's see, this is at about, like between about 10 to 30 miles up into the atmosphere. So this is very, very, very far. And it's not a place where we go, unless you're in a rocket ship, right? And it's not a place where we have rain or anything like that. So who cares? Well, there's a branch of meteorology and atmospheric science that studies the stratosphere. There's a lot to learn from the stratosphere. There are a lot of circulations in the stratosphere. It's difficult to really imagine because the air pressure there is so low. I mean, we're talking about where this happens, which is between this layer, which we call 10 millibars and 30 millibars. It's about 1% of the atmospheric pressure we have at the surface. So it's equivalent to like the type of atmospheric pressure you would have on Mars or something like that. It's extremely low pressure that high up. In other words, you wouldn't be able to breathe. You couldn't survive up there. But there are wind currents. And so there is a current that goes around the North Pole and the South Pole that is called the polar vortex. More specifically now, it's the stratospheric polar vortex. So why do we have to make a distinction? Well, because up until probably the 90s or so, when you talked about polar vortex, you were strictly talking about the stratosphere. And this was just referred to as the polar jet stream. In recent years, though, there's been a little bit of a shift to referring to the stratospheric polar vortex and also the tropospheric polar vortex, or if you want to get really fancy, it's called the circumpolar vortex or the tropospheric circumpolar vortex. All this is to say that if somebody wants to be really technical and somebody wants to correct you and go, no, 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 the polar vortex in the stratosphere, you just tell them, look, Mike said, in common usage now, they're talking about, lobes of the polar jet stream. And so let's just get that out of the way. The jet stream right here sometimes flows very straight, and we call that zonal flow, just like this is showing. And when you have zonal flow, you typically have pretty tranquil, uneventful weather. Whenever there are ripples in the jet stream, that's where you get cold fronts forming and active weather and severe weather and things like that. But when it's just flowing like this, the cold air stays trapped to the north, and you have sort of like mild, seasonable conditions to the south of it. But it doesn't always stay that way. So when it's like this, everything is kind of like just fine. There's not a lot to talk about, right? The cold air stays where it's kind of supposed to be, and the somewhat milder air stays to the south. So in this regime here, you'll have somewhat above average temperatures and sort of more tranquil conditions and more sunshine and things like that during the winter months, whereas areas from the Dakotas up to Canada and then obviously areas to the north will just get like crazy cold with very little change in their pattern. Now, what happens when that flow of air is no longer straight or zonal? Well, you get this, what we call like an amplified pattern, or if you want to think of it as a bumpy pattern. That's where you have highs and lows, or what we call ridges and troughs. So you'll get a ridge forming over some areas, and if you're under that ridge, generally you'll be clear and on the warm side. And if you get caught under one of these troughs, that's what pulls down the colder air. So this has been what's been happening a lot this winter, especially January and February. We've had big lobes of the jet stream drop unusually far to the south, which allows this Arctic air to drop down. Now, it does get really complicated here. Like, does the jet stream like move the air down? Not necessarily. There's a dance that goes on between what happens at the surface with the cold air, with areas of high pressure and low pressure, and it's connected to the top parts of the atmosphere. But I will tell you that where the jet stream is, it tends to set itself up over the areas of the greatest temperature change. So that basically along fronts. So where you have really cold to the north and really warm to the south, you're going to have a strong jet stream flowing along that area. And where it takes a big dip down, that's what carries the Arctic air with it. So this is a situation in which we found ourselves for a lot of this winter. Now, when you get caught under the H in this sort of setup, then that's where we would go through what we had in the early parts of February, where we had record high temperatures. The cold air was displaced to the north. You might have cold air up in the Pacific Northwestern United States, cold air over on the east coast of the United States, but in the middle part of the country where we are, just during that 1 week, we had really unusually warm air in place. And like I said, made it all the way up to 86 here in Houston, made it up to 88 in Dallas. So that is a completely different scenario from what we saw with snowstorm and things like that when the polar jet took a big dip to the south. So when you have a disrupted vortex, okay, when there's a disruption in the circulation of winds going around the poles here, then you get amplified sort of arrival of cold air. So instead of just staying up there where it usually comes, you get little lobes that'll break off. So usually that purple area is up by the North Pole. When you get this really bumpy jet stream, little pieces of it will come down from the North Pole, and you could actually watch it like it's up in northern Canada, Greenland, and it'll just drop. That same piece of air, it's literally the same air, will drop down into the United States whenever you have an amplified pattern like this. So when you talk about polar vortex, letter of the law, scientific book, old school scientists, no, that would be something that happens in the stratosphere, which has a very complicated relationship with what happens in the troposphere. It's one of those things that's an active area of study. It's very difficult to explain or even understand. The air up there will like heat up by 50 degrees. It's called sudden stratospheric warming. And sometimes that'll be linked up with colder air moving down into the United States, but it's not like a 1-to-1 ratio. It's not like if this happens, then that happens. It doesn't really happen that way. But the bottom line is when you hear polar vortex, it's nothing new. The media gets a hold of these terms and they like to use them. So pretty much these days, anytime you hear the polar vortex has arrived, all it really means is that the polar jet stream here has taken a big dip to the south and allowed cold air to come down out of Canada. A little bit about La Niña. So things have not worked out normally for La Niña. If you'll recall, we have this oscillation in the Pacific Ocean called the ENSO, E-N-S-O, which is the El Nino Southern Oscillation. Southern oscillation just means that it's on the equator and it's this oscillation, this sort of sloshing back and forth of pressure between one side of the Pacific Ocean and the other side of the Pacific Ocean. And it sort of like goes back and forth. For a year and a half, there'll be more high pressure in the western part of the Pacific, and then it'll switch, for another year and a half. So you go on this cycle of like every 3, 4, 5 years. that the water gets kind of pushed back and forth in different ways so that you'll either have warmer water near South America, which we call an El Nino, or you'll have colder water, which we call La Nina. And there's a connection between the temperature of the water there and the weather that we typically see here in the United States. For example, during El Nino years, we have fewer hurricanes on average. We tend to have approximately double the number of hurricanes in La Nina seasons than we would in El Nino seasons because of the way the jet stream is affected. We also tend to have very different winters. The effect on summer weather is like not as well defined. The effect on winter weather usually is that during El Nino years, we tend to be wetter, cloudier, kind of dreary all along the Gulf Coast from Texas to Florida. Not as many temperature extremes, but just kind of yuck. Usually in La Nina years, we tend to be drier and milder. And in fact, when NOAA's Climate Prediction Center came out with their winter outlook, which was released in November, the outlook for December, January, and February called for a general pattern of above average temperatures and below average precipitation. And when we pointed that out, I was sure to tell everybody, hey, look, having a warm winter doesn't mean you're not going to get cold. It just means on average, you're expected to be above average. Well, that hasn't really worked out. It really hasn't. I mean, we had very much cold trending weather, including a blizzard on the Gulf Coast, a Louisiana blizzard, a Southeast Texas blizzard. We were not technically under a blizzard warning, but Beaumont was, Port Arthur was, Louisiana was, all the way back over to the heavy snow that happened in Florida, like 10 inches of snow in Milton, Florida, north of Pensacola. And we had about 3 to 4 inches of snow in Harris County, some spots a little more. So these extremes are not something that you would typically expect during a La Nina winter. The challenge of that is you talk about averages. So if you were to take, if you were a forecaster and you saw that a La Nina was setting up in the Pacific Ocean, and somebody said, what's the winter going to be like? Well, you would say, on average, drier than normal and warmer than normal for Texas. But that's on average. It doesn't mean that every single La Nina year is going to exhibit those types of patterns. And this is one of them that just didn't. Now, we are switching back toward a warmer pattern here. But really, by and large, the La Nina has really not behaved so much, this year. So, that's the way things are working out. As far as what to expect in the upcoming days, I have some graphics here I want to show you. Well, not just upcoming days, but upcoming weeks and months, actually. So we have a look ahead at the precipitation, or excuse me, the temperature outlook. Actually, the precip outlooks show kind of average conditions, average or even slightly below average precipitation. When we take a look at temperature forecasts, though, the temperatures do look like they're trending warmer. Of course, keep in mind, they looked like they were trending warmer this winter also, according to the Climate Prediction Center, and that didn't exactly work out. But eventually, everything comes around. Eventually, everything returns to average. It equals itself out. If you have a really cold, number of days, you end up with usually a really warm number of days to average everything out. What you would call like a reversion to the mean. And so the forecast is calling for, in the short term here, heading into next month, for example, that we're likely to have, on average, above average temperatures here in Texas. In fact, most of the country should be above average to wrap up the month of February, to head into March, which of course is rodeo season here in Houston, and it looks like it's going to be on the warm side around here in general for rodeo. The mornings will be brisk. We may have some brisk mornings, but in general, we're looking for warm conditions. And then as far as the summer outlook, I know it's kind of early to think about summer. We haven't even made it to spring yet. But when you take a look at the forecast for June, July, August, which is what we call meteorological summer, the outlook is also for above average conditions, not just in Texas, but across basically the country, across the United States of America. So we probably will have quite a bit of, forecast challenges like we always do, weather that's going to be affected by rainfall and things like that. That will temporarily cool you down. And of course, the wild card is always the tropics. It is far too early to say whether or not we're going to get hit by another hurricane. Of course, we had Beryl last summer, and hopefully we don't see another one. But this just goes to show you also, and I've never been a fan of them. I tell everybody the information because I know everybody wants to know. But whenever these seasonal hurricane forecasts come out, we'll get the first one in April from Colorado State University. We'll get another one right at the beginning of hurricane season, end of May. Sometimes they wait until June 1st, I think, from NOAA, with their outlook for the season, where they give a range, we're going to have between 16 and 20 named storms, or this many, that many hurricanes. Beryl was the second storm of the season, right? And it hit us. And if there were no more storms the whole rest of the season, that we got ours, right? Which, by the way, is there's some debate right now as to whether or not it might have been a Category 2 and not a Category 1 because of the extent of the winds inland, but that's a topic for another Mondays with Mike. But just know that whenever you're doing these long-term seasonal forecasts, like basing things on La Niña or taking a look at a seasonal hurricane forecast, you always have to take it sort of with a grain of salt, saying that this is the forecast is based on data. Nobody's just throwing darts, you know what I mean, to try to come up with the forecast. It's based on historical data. When we have this, then usually this happens. This pattern usually leads to this outcome. But it doesn't always work out. And sometimes you could have a very quiet hurricane season and you get slammed with a hurricane, or you could have a very active hurricane season and nothing hits Texas. Sometimes you could have a La Niña winter and you get slammed with a blizzard, which is what we had along the Gulf Coast. So yeah, weather is very, very complicated, which is why we stay very, very busy here as weather forecasters. So that'll do it for today's Mondays with Mike. I hope next time you hear the term polar vortex, you'll kind of understand what the media is talking about. You won't hear it from me, honestly, but you'll probably just hear it, out in the ether of the media and on social media. When you hear polar vortex, we're talking about a shift in this jet stream, allowing the cold air to come down. And I don't know about you, but I've had enough of it. I just want some normal weather. No more super cold stuff. Anyway, I want to thank you so much for joining me here for Mondays with Mike. I want to say thank you to the folks who wished me a happy birthday. I don't make a big thing out of my birthday. I don't know. It's just not my thing, but I do like spending a birthday with my family and everything, and all that kind of stuff. So thank you for everybody who reached out. It wasn't the big one for me. It was not the big one, but that one is right around the corner. Yeah, exciting stuff. So shout out to my mom and my brother and everybody else watching out there. I hope you have a wonderful start of the rodeo. Hope you guys really enjoy the barbecue cook-off. Get you some brisket or maybe some vegetarian options. They probably have some out there. Hopefully they do. Thanks so much for watching, guys. Also, just a shameless plug, be sure to tune in whenever you have a chance, each Monday through Friday at 11 a.m. for Forecasting with Friends, where sometimes it's one of us, most of the time it's two of us, either me and Allison or me and JD, or sometimes Allison and JD, and we do some interesting weather stories, some in-depth weather stories. We always save animal stories for Furry Friends Friday. It's a blast. So join us there daily at 11. Hope you have a wonderful day. Take care of yourself.